We're, many of you know, but most of you don't know that one of my former students is Atul Butte. And among the people who he most admires for just having synthesized the whole precision medicine stack to the consumer is Jessica Richman. And so when he told me about that, and I saw that and I knew immediately I agreed with him, it became clear to me that it'd be wonderful to have her as our closing keynote speaker. And so I'm really, really grateful for Jessica for having come here. She really represents, in my mind, a lot of what I hope for and what my colleagues hope for in the department should occur as leaders in this new field of precision medicine, understanding the measurements, understanding the computation, understanding the clinical need, and then packaging it into a service that actually scales to a very, very large level. And so I'm going to just leave it at that because, again, as in our other talks, I think it's much, much better rather than giving a lengthy introduction to let a speaker introduce themselves and describing their own journey. So, Jessica, thank you very much for making time for us. Thank you.
So hi, everyone. Thank you so much for having me here today. This has been really amazing. Every story that I've heard and every person that's trying to take data and apply it to medicine and turn it into answers that people can actually use right now is just, this is what we're all about, and I'm so glad to be here and be able to talk with you about the attempts we've made to do something similar and to be part of this community of people who can do this and who can really have a big impact on healthcare. So this is our team now, our management team. So there's me and my co-founder, Zach, and we have this great leader, the woman with the most patents in the United States, actually works for us. She's our VP of R&D, and we have a CFO who went to Harvard Business School, not medical school, and we have built out all this stuff. But we have over 100 employees, but it all started with this crowdfunding campaign, which was kind of a crazy way to start a biotech company. I think we're the only venture-backed biotech company in history to have started with a crowdfunding campaign. I've never heard of anybody else doing this. And why did we do this? That's a really good question. I'll go into that and then kind of where we started and now kind of what we were able to turn that information into, and then maybe some ways that we could all collaborate together if there's anyone who's interested in doing that. So we started off, so my story, I studied computer science and economics at Stanford. Then I got a fellowship to go to Oxford to do a master's and a PhD in computer science and economics together, which is computational social science. So it's basically large social science data sets, like the LinkedIn data set, computing interesting metrics to prove social science theories or to verify specific hypotheses. So I was looking at networks of people on LinkedIn, how they relate to each other, how you can tell who adds more value to a network, things like that. And you would think that's the furthest thing in the world from healthcare. But as it turns out, I was doing that work. The math was really interesting. I was very excited about kind of the potential of those kinds of computational techniques. But what I was not excited about was, great, I'm analyzing the LinkedIn data set. And at the end of it all, who is going to benefit from this? Like, how am I actually going to have any impact on the world? So I met my co-founder, who was doing his PhD at UCSF in biophysics and computational biology, essentially. And we started talking about how we could use those same kinds of computational skills in genomics. And I thought for a while, should I drop out of my PhD and start a second PhD? Should I go get a postdoc when I'm done? Like, what should I do? And we decided, what, actually, no one in academia has this data either. What if we did a crowdfunding campaign and we saw if we could gather this data? So we did this crowdfunding campaign. At the time, it was a big deal to be top 15 on Indiegogo. This is a very old slide from back in those days. And within 10 weeks, we raised $350,000, and we'd collected samples from over 2,500 people. And I'll tell you more about this later, but at this point, the state of the art was a data set that only had 242 people in it. That was the big NIH-funded data set from the Human Microbiome Project. So when we saw this, we decided, okay, this is really something. Like, who the hell are we? We're these grad students. Like, how do we have the largest data set in the world of microbiomes? And we thought, okay, well, we have this great responsibility now that we have this data to use it to do important things. So I'm going to tell you a little bit more about that story. So right now, just to kind of cut to the chase, we have the largest microbiome data set in the world still. We did when it was 2,500. Now we have over 150,000 samples. We have committed through researchers that we're working with over 500,000 samples. So we have like this tremendous capability for understanding the microbiome that no one else has. And we want to use this to make useful products and services that will really help people. So for those of you who don't know about the microbiome are the bacteria and other microorganisms that live on and in all of us. They've been correlated in hundreds of studies to all sorts of different things, everything from human development to mental health to reproduction to digestive health to acne to kind of you name it. It's kind of like saying, what is the genome correlated with? It's correlated with everything, right? Because they live on us, they drug us, they digest our food for us, they do all sorts of things for us. So what we want to do was take the data that we built and turn it into something useful that could help to tackle some of these specific areas. And we kind of viewed ourselves as being in this grand tradition of using microbes to affect human health. I mean, the first thing is, the invention of yogurt, bread, and beer. Like, what could be better than nourishment and intoxication? And then, from there to the germ theory of disease, discovery of penicillin, CRISPR, and then this idea of using microbiome data to diagnose and cure disease with microbes, which has never been done before. So there's been this dramatic growth in microbiome publications from the very, very beginning when the word microbiome was coined in the mid-90s to when this stops at 2014, which is when our data set started to really get going. There's this massive growth in publications, but there wasn't this accompanying commercialization of this information into something that people could actually use. One of the things that we realized when we started the project was that meaningful inferences about the microbiome really required a larger data set. So the Human Microbiome Project was supposed to be like the Human Genome Project. It was a $173 million NIH project that studied 242 people. And this was the impetus for us starting this crowdfunding campaign, and our great surprise when we realized that we actually built a bigger data set than this and we could actually do something with it. MetaHit is the European equivalent of that. It wasn't one single project, it was a consortium of different university-based projects. Altogether, let's say it was about 500 individuals. So at the point that we started our crowdfunding campaign, less than 1,000 people in the whole world had ever had their microbiome sequenced. So we were able to really kind of grow past that, but then we didn't want to stop there. We wanted to say, okay, how do we use that? And the reason why, and this is, I think, really important to this specific group, the reason why people gave us this data, because you could say, so who are these people on Indiegogo? Why would anyone want to give the data to them? Is this idea of citizen science, which I think is really, let me just skip ahead to this slide. So all the things we've been talking about today are really kind of the same thing, right? So citizen science, that should be, stage 4 clinical trials, patient-centric medicine, the quantified self. All these things are large-scale studies. They all kind of converge in the same way. They're basically involving the patient, the participant, the whatever you want, the people in science, in whatever role they happen to be. So I think that we called it citizen science. That's not a name we came up with. I'll tell you a bit more about that term. But citizen science is this idea that citizens can participate meaningfully in science in the same way that precision medicine is a way that individuals can have medicine tailored to their needs. And I think that this kind of convergence of this rise of the power of the individual and this convergence of all these things is the most powerful force in medicine, and why I'm so glad that we're all working on this, because I think so many of the inefficiencies and problems in the system that we all see are caused by having the individual not at the center of the process. The individual is this object that gets moved around among care providers and isn't a human being who gets to use their capacities to better understand their health or to contribute to science or to be an active research participant. So citizen science is a term that was created by ornithologists in the 1970s, so we can't take credit for that term. Basically, they had the realization that these ornithologists at Cornell realized that there are many more bird watchers than there are ornithologists. And that kind of makes sense, right? There are many more amateur everything than professional everything, right? There are many more amateur basketball players than there are professional basketball players. So if you think about it that way, you realize that, maybe if you're an ornithologist, you want to use these bird watchers who are going to look for birds anyways and use them, and they want to be used to answer questions that are interesting and meaningful. So instead of just looking at birds for their own pleasure, which they can also do, they can also use that pleasurable activity to contribute to others. So that's where it started. There are a number of hundreds of different citizen science projects, not in many different fields. We applied this to the microbiome, but there are many different projects, and they're fascinating. They're really great to get involved. There's a company called SciStarter that you guys can look up, especially if you have kids, that you can filter by projects that are friendly for kids, and your kids can get involved in science. It's a way to really meaningfully contribute. So two of the other projects I think are really interesting is to look at ocean plankton. They use sailors to do data collection, which makes a lot of sense because there are many more sailors than there are marine biologists who focus on plankton. So they've gathered this massive data set of ocean plankton, kind of in the way that we did with the microbiome. And then this one on moral decisions I thought was really interesting. This is a very recent one where machines, when they're designing self-driving cars, for example, do you want the car to kill the driver or the pedestrian, right? These are very important moral decisions, and you can pose those to the crowd at a really large scale and see, what do humans generally tend to do? Like, what is the decision that a human would generally make? And instead of just relying on the opinions of the designer of the technology, you can see whether or not you want to follow it is a different thing, but you can kind of see what do people do in different cultures and places? How do they make these kinds of decisions? So I think the broad application of citizen science is something that's really, really important. So I think, I'll just posit this, I think that the future of science is a crowdsourced and collaborative effort. There are 7 million scientists, meaning people who have PhDs, who work in research facilities doing science. But there are 7 billion people, and there are many more people who can think creatively about science or can think about science that's not in their field. And being able to bring all of those, their data, their hypotheses, their ideas, their opinions to science will make all of science richer. So I think this is a really important thing, especially for all of us to think about as scientists. How do we involve the public in what we do? We did this with the microbiome, and we did it as a company, but those are not necessary preconditions. You can do this as a nonprofit, you can do it as just a researcher with a grant budget, and you can involve the public in a way that adds to the data, and you have to have rigorous standards for all kinds of things, but you can also involve the public to the degree that you can. So we call that crowd science. So one of the things I want to talk about is kind of doing citizen science right, because there are a lot of things that we learned and that we hope that other people can learn from the beginning. We were the very first study to do this kind of crowd-funded approach to microbiome research. So we learned a lot about having an IRB, paying special attention to privacy and security. We're covered under HIPAA now because we're a clinical lab, and so we're a covered entity, so we comply with all the things you're supposed to comply with as a covered entity. But at the time, we were not, but we voluntarily decided to get IRB approval, which we did not need to do. We voluntarily decided to make public live information about how we kept data private and how we stored it and who had access to what, which wasn't legally required, but we wanted to build trust with our participants. We wanted to make it foolproof and to listen to the participants. We found out all kinds of fascinating things. I mean, this is one great thing about starting a company as a crowdfunding campaign is people use your product in ways you never would have anticipated. They do, one of the first questions that we have is we did 5 sites, which we still do, the nose, mouth, skin, gut, and genitals to sample the microbiome. And we had trans activists who wrote to us and said, what about the genital sample? Like, how do we, can we create a trans cohort and analyze that separately? Like, this was something that had not occurred to us at all when we thought, those are the 5 sites using the Human Microbiome Project. Let's just do the same ones, and then we have some data to compare it to. And listening to participants and kind of hearing what people wanted really helped guide where the product went, but it also helped us think of use cases that we would never have thought of otherwise. And then thinking a lot about how to collect samples, so specifically how to make that process really user-friendly. So our clinical test that I'll tell you about that we developed from this data uses the same sampling procedure that we invented in 2013, that we filed some patents on, that basically you swab your toilet paper with with a swab. Previously, stool collection, if any of you have had to do this, is not an easy or convenient task. I can see some people shaking their head like, no, don't ever make me do that again. And we designed this very simple collection procedure because we wanted to make it easy for people to participate. We realized people would not want to go through a stool collection procedure if they, just to contribute to science. We want to make this easy. And that procedure has been really valuable to us, as we've continued as a company as well. So thinking about how to involve people in a way that considers them as human beings and what they need, and how to build something kind of like Jill was talking about with color, where taking this design-centric approach where you treat the patient or participant as a human being and give them an experience that they will appreciate. So some of the lessons that we learned from citizen science that I think can be applied to precision medicine more broadly. So one question is, what does the participant get out of it? It's a really important thing. I mean, if you have a patient, a cancer patient who, it's very obvious what they get out of it. Like they may get data that could save their life. But if you're doing more basic research, or if you're doing something in a chronic disease population, which is what we ended up building our clinical test for, you want to make sure that they get something valuable for themselves, that there's an altruistic motive, but it needs to be aligned with a self-interested motive. So you kind of want to combine those two things together as much as you can. Another one is about, like I was saying earlier, this need for empathy. It's really important. I mean, as we're all patients, we've all experienced this, like that intense dripping condescension that you were talking about earlier, where the doctor just treats you like you, this distinguished researcher, like you're an idiot. Like we want to make sure that we don't treat people that way, and we treat them with empathy, and that their concerns are important, and whether they're a research participant or a patient. And then one of the things that we just kind of learned from a startup perspective is there are problems of success and there are problems of failure. And you can deal with the problems of success after you've had the success. And I think a lot of times, especially in the academic projects that we've done, people are planning for, oh my God, what if we get 10 million people? How will we store their data? When really, like when you have 10 million people, you can just worry about that then. A lot of the things that we've had to learn to do have been around, let's give people good experience now. Let's plan the ethical and legal structures that we'll need for the future, but problems of success are problems that you can deal with when you have success, and if you can really stymie yourself at the beginning if you have to plan for every positive eventuality. That is not true of negative eventualities. You should plan for all the negative eventualities to the degree you can. You're going to get hacked, people are going to hate you, like all those kinds of things you should plan for as much as you can up front. Because those can happen even if you don't have success. But the success problems can only happen if you do have success. So one of the things that we noticed when we first, after we launched this crowdfunding campaign, we had all these individual citizen scientists, is that a lot of institutional scientists came knocking on our door. Because at the time, in 2013, 2014, people didn't, people could do microbiome sequencing at their university lab, but there wasn't this sort of broad, it wasn't easy to do. Often it was really slow timelines, no guaranteed results. It was just, they were a lot of researchers that were in the field were in the same situation of people who were out of the field. So we decided to, initially we worked with research partners and we charged them because we hadn't raised any money and we needed to, but now we give away grants to research partners. And we worked with over 200 research partners around the world. That's how we have these 500,000 samples that we've committed through research partners, where we essentially give them a grant to do microbiome sequencing, and in return we get the commercial use of their samples, and they get the academic and scientific use of the samples. So one of the things that we did with the Obama White House was they had an interest in the microbiome, which was kind of crazy. I figured they were digging very deep in science if they were digging all to the point where they invited us to go talk to them about the microbiome, which made me very proud of them, in fact. We give away these microbiome impact grants to researchers that we think are doing really interesting research, but that can't get funded in traditional ways. They're kind of like we were back when we started the project, and there was no way a grant was going to pay us to have this big data set and see what would come of it. And in that same way, a lot of researchers are kind of in that same situation now, and we offer them grants now that we can. So here are some of the researchers that we work with. We work with the CDC, for example, to look at predisposing factors for hospital-acquired infections, preterm birth in the microbiome. We're doing a study with the NIH. Basically, you can see by the breadth of these, where it's eating disorders and cardiovascular health, and you might think, what do those two things have in common? The idea is we're building the largest data set in the world of the microbiome that grows, not only is it the largest now, but will remain the largest. And we just can do a lot of different things, right? So a control for the smoking study could be someone from the cardiovascular health study, for example. And we can, by getting data from all these different sources, we can combine them together to come up with new insights, and we've filed over 100 patents at this point, and a lot of them are based on the insights that we've gathered from this data. So, and this has led to some publications. We had one recently that's kind of, how does our test Smart Gut work? And that's this one that was in PLOS One in May. We've done a bunch of presentations at different places. We have some new publications coming out as well. But all of this data gathering led to our first clinical product. So the mission with uBiome from the very beginning was, build a big data set, turn it into something useful. And the question is, what do we turn it in that's useful, right? And that was based on what kind of data we gathered, what needs we recognized, what we were able to get paid for, what people needed and wanted. So what we came up with was our very first test, which is SmartGut. So SmartGut is a test it's a gastrointestinal test for people who have chronic gut conditions. So we identify specific pathogens. We also have specific organisms can be associated with IBD versus IBS. So it helps clinicians make a decision of, is this more likely to be IBD or more likely to be IBS? It's not a diagnostic in the sense that it doesn't come up with like a bright red yes that says you have IBD or you have IBS, but it's a better guide to treatment than what we currently have. And it's, I think, in a lot of ways, a really good example of personalized medicine in that you can test to see what you're more likely to have, and then you can pursue a course of treatment that reflects that rather than just doing blind trial and error. Your story really touched me earlier about doing that for cancer. This is much less urgent than that is, but that idea of being able to know what you're dealing with before you get started rather than just trying random stuff and hoping that you get there at some point. And we find that patients we talk to have suffered for 10 years sometimes on this diagnostic journey where they're no one knows exactly what they have. They do a colonoscopy, they can't find anything, so maybe you should just change your diet, and you do, and it kind of works, but you're not sure how. So the idea of SmartGut is, what are you most likely to have, IBD or IBS, and then monitoring over time to see if your treatment is working. So we use the same sample collection methods that we use for our consumer test, but this is just to be clear, this is a doctor-ordered test. So we are CLIA certified, we are CAP accredited, we've done all the things, we are HIPAA compliant, there's a whole set of rules and regulations that we follow to make we're just like any other clinical lab, like Invitae or Council or, Complete Genomics or whatever. And the idea is that we can apply those same techniques that people use in genomics, of lab-developed testing to this world of the microbiome. And we still have our consumer and research product, which is now called Explorer. That was the original product that we launched with. And we now have this clinical test, which is truly a medical product. We've done the successful translation of translational medicine from the microbiome's interesting, learn some stuff, all the way to here is a real medical test that real doctors prescribe and is processed in a real clinical lab and reimbursed by real insurance companies. So how did the data help us do that? So I think this is a really interesting question because you could say these two things look very separate from each other. Why are you doing a smoking in the oral microbiome study with Yale over here and then you have a gut clinical test? Like, what do these things have to do with each other? And what we're aiming to do is to gather a big data set that yields previously unimagined insights, right? So there may be something in that oral microbiome that then influences the gut microbiome in IBD patients. We don't know. But if we gather enough data, we can find interesting correlations, and then we can make sure that they're actually useful by looking in the literature and then putting them on a clinical test. So here's an example of how to make a test from data. So there are three major ways in which the data helped us to make a test. So the first way is to figure out what targets do you put on a test like SmartGut. Like, no one's ever made a sequencing-based clinical microbiome test. This is the first one in the whole world ever. So the question is, what do you put on it? How do you know? So basically what you do is you figure out what you can detect, and we know that we can detect more than anyone else in the whole world because we have the largest data set in the world. Then we review the literature, and this was a multi-year process. This is a very time-consuming process where you go through every paper and you see what targets specifically they're looking at. Can we detect it? Can we differentiate? So because we have this big data set, we can differentiate between targets that people had previously said were impossible to differentiate. We can do it because we have this extra data. So we have a list of all the stuff that you can detect, and then we have a list of all the stuff that's important, and then we take the intersection of those lists, and that's how we decide what to put on the test. Can we? And as Jill from Color said, analytical validity is kind of table stakes. Like, yes, the test does what it's supposed to do. Yes, you give results in a HIPAA compliant and CAP accredited manner. But how do you make sure the test is actually useful from a clinical validity perspective? We did that by doing this really deep dive into the literature. And then the second thing is, for some of these bacteria, no one had ever set healthy ranges before. right? Because they've never been detected in large populations before. So how do you figure out what is healthy and what is not? So for the pathogens that are on the panel, we already know that, because for the pathogens, people have been detecting those pathogens for a really long time. There are established healthy ranges. We compare to the existing gold standard, and when we meet the gold standard, we say, great, we achieved that. There is a gold standard. For the commensal bacteria, there just aren't gold standards. So we had to set them. So out of our 150,000 samples, we pulled out people that were healthy by a set of very rigorous criteria. There were 42 questions that people answered that had bearing on whether or not they were healthy. And we've out of the 150,000, we selected 897, and we used those to make ranges. And this was what we put in our publication in PLOS, was what are these ranges? How do we know? Who are these healthy people? How do we tell? And that let us make these healthy ranges that had never existed before. So that's a way that, without this data, there would be absolutely no way to do that. You wouldn't be able to pull out this kind of population. And then the other thing is to have high sensitivity and specificity on all the targets. So I'll go into this a little bit, but on our test, we have 98% or higher specificity on every target. And the way that we do that is that there are public databases of genes. We have a private database from these 150,000 people that's way more extensive. We use that private data to make a cleaner version of the public database, and then we can find high sensitivity and specificity that other people can't find. So without the data, this test just doesn't exist. So, and here's an example of that. So we test for a couple of pathogens on the test. You would say, looking at the regular 16S gene, you would say it's impossible to distinguish. You have 7% sensitivity, so you can't make a test. But using what we've developed in our data set, using both 16S sequencing and something we're calling precision sequencing, which is 16S plus full metagenomic sequencing for targets that are harder to differentiate. Using that technology, we've been able to have really good sensitivity on this test, and we can actually use it to make these distinctions that wouldn't have been possible otherwise. And then here's just this was part of our CAP inspection. We had to go through this huge validation process. We looked at hundreds of samples, and we went through and you check all the things that you're supposed to check. Kind of, we were talking about analytical validities, kind of table stakes. Here's how you ascertain that. And then let me go to, and then as part of CAP, there are a lot of other things that go into it. So in thinking about translational medicine, I find people always have this kind of weird paradigm where they're like, it's so hard to invent the thing, and then magically, it turns into a product, 10 years later, and no one talks about all the steps you have to go through to get from here to there. Maybe it's a trade secret or something. There is so much you have to go through to get from here to there. A research lab that gives people fun information about the microbiome is a very different thing than a CAP-accredited lab that has all sorts of regulatory frameworks around it. So I want to make clear that there's a lot that goes into that. But I think that in terms of policy changes, making it easier for people to be compliant and to learn all the things that they need to do in order to be compliant would be really valuable, because if our goal is to take knowledge and turn it into stuff people can use, this is how you do it. This is how you make sure that the stuff people are using is valuable and is accurate. So, and then we're licensed by CLIA and by CAP. So basically, we took all this data and we turned it into a test, and that's great. We have a number of other tests that are coming out later this year that are kind of on the same theme, where we took all the data and we turned it into a test that we believe is unique. But one of the things I wanted to talk with this group about is what we've been calling uMi, which is the uBiome Medical Informatics Initiative. I know there are a lot of people here that are in medical informatics. And one of the things we love to do is partnerships like the research partnerships that I talked about with scientists and doctors, both on the pure research level and also on using our test for specific applications. Because we found the first application of it, which is distinguishing between IBD and IBS to help guide diagnosis and treatment. But there are so many other things that you can do with the gut microbiome, and we're eager to kind of make different versions of this test that are useful in different audiences. We have a researcher in South America who's using it for cancer research. They're apparently gut microbiome effects of absorption of specific drugs in the type of cancer that she works with. And the idea is, maybe SmartGut can tell whether or not the drug will be more effective in her population. There are also risk factors that we have on our new version of the test for diabetes and kidney stones and all sorts of other things that are also correlated with the microbiome. So what we're looking for in general are partners to work with to find new applications for the technology, because we've already built it. And the more we can do to involve other people in it and work with researchers to make it valuable is good for us, and I think good for the world. And there's always this tension between, oh, you're commercial and you're selling something, but I think there's also this point of, we give away a lot of tests to research, and we do that because our mission is to make the microbiome useful, and giving things away to researchers is mostly how you do that. So I'll just give some examples of how we've done this in the past, and if anyone's interested in doing this, we'd love to talk with you about it. So one of them is for collaborators. We can find controls in our data set that can make it easy for you to do comparisons. For the eating disorder study I was talking about, they have 17,000 people with eating disorders. We have, hundred thousands of other people, over 100,000 other people who don't have eating disorders, and we can do interesting comparison studies. We can age match controls, gender match controls, things like that. We have this platform that makes it easy to source populations or integrate medical records. We do free microbiome sequencing. And then with partners, what we get is a bigger data set that we can use to compare data back and forth. So here's an example of a use case of a regional cancer center. One of the things that we're using is kind of this idea of, we don't know all the applications of the microbiome in cancer. We have some in mind, some we found in the literature, but we'd like to just try it out in different places and see if the information's useful to people. So this is something we'd like to pursue. Something similar with metabolic disorders. So we know that the microbiome is deeply involved in diabetes and prediabetes. There's this bug called Akkermansia that some of you, if you're in the microbiome world, you've heard of. It's the weight loss bacteria is kind of the hypey way to put it. But basically, it eats a lot of carbohydrates and turns them into heat. And if you have a lot of it, then you're way less likely to turn your prediabetes into diabetes. So this idea of how we could work to prove that out from a clinical perspective, to have a larger population in which to work with, that's something we'd be very interested in. And then there's this really interesting idea around allergies and inflammatory diseases. So this is, there's the hygiene hypothesis and this idea that, if you have an environment that has a really rich microbiome, your immune system will develop more appropriately. The development of the pediatric microbiome over time. We're doing some research studies on this, but if other people are interested in doing this too, we would love to do that. One of the things that I think is really interesting are the relationships between gut, oral, and nasal microbiome. Typically, everyone, and ourselves included, tends to focus on one microbiome. How does the gut affect the gut condition? How does the nasal microbiome affect the nasal condition? But there are a lot of interesting interconnections that happen that we'd be interested in looking at too. And then women's health. So we're making a big effort here. I think that we're a women-led company. I'm the co-founder and CEO. We have a executive team that's almost half women. We have a employee base that's almost half women. Like that's almost half is saying a lot actually in Silicon Valley. So we want to be able to make this push for women's health. And there's some really interesting links between the vaginal microbiome and women's health. We have some applications we're already developing. We'd love to develop some others with anyone here that does that kind of work. And I think there's a lot of really interesting work that can be done there. So just to kind of sum up, I'd say that as doctors or as scientists, we're all also involved. We're all also people and patients that are involved in this really in this new world of moving from these institutions that control what data we have access to and what gets turned into a product and who gets to do what. And we're also patients who want to disrupt that system at the same time. So I think that as people who are knowledgeable about this field and also want to empower the individual, I think we have this special responsibility to help this convergence happen more quickly and help it happen in a way that benefits the patient and that turns into answers for all of us. So thank you.
Stay there, Jessica. Wow, that's an impressive achievement, more than I had anticipated. And while the crowd gets its thoughts in order for questions, I find I have a lot more questions than I have time, so I'll just pick one. So what about if I'm in this uncomfortable middle zone, which is I'm not just curious about my microbiome, but I saw my GI doctor, and she said I'm fine. But I'm not feeling so great.
Right.
And I want to take that new test that you just described.
Yeah.
But I just heard you say that it's well funded by the payers, but I'm not a payer.
Right.
So what are you going to do for me?
That is such a good question. And that's, I mean, I'd say most of our users are in that situation, because if they were getting good care, well, I mean, they're getting good care, they're going to get standard care, but if they were getting their questions answered by their GI doc, they probably wouldn't be looking for this. So for that person, we offer two things. So for people that have a medical need, meaning a doctor, they have a reason for a doctor to prescribe the test. Similar to Color, we have an external care coordination network that we work with that can find a doctor who will prescribe the test and who will counsel you on what your results mean. So we do that separately. We also engage with doctors, so we do this program that's part of our doctor program, where if you tell us who your doctor is, we will contact the doctor on your behalf and ask them to order the test and tell them what it's all about and explain to them. For us, it's sales, but it's also for that individual patient. We will hunt them down and try to get them to give you the answers that you need. And payers will pay. You know, we currently were in a pilot stage. We launched this about 6 months ago. So we don't charge the individual patient. We bill insurance, but if they don't pay us, then we just don't get paid. We won't do that forever, but in the short term, we're doing that because it's, you know, part of driving adoption of the test, and it's also to kind of get a broader base of people that can use it, that may not be able to afford a copay for it. So yeah, so that's what that's the situation most people are in, and we definitely want to encourage them to use SmartGut and to see if it's helpful for them. For people there are also people who are kind of more on the side who don't have any medical condition at all that a doctor would prescribe it for. They're just curious. They want to try things. Sometimes doctors will prescribe as a baseline, you know, get this test done once and just see what's there. Sometimes we can do that. Or people can just use Explorer, like the same sort of health and wellness tool that we've had. We've improved the features and we've made it better. And basically, you know, if you're curious what foods are good for my microbiome, or is my probiotic working, we can answer those on the health and wellness side.
Okay, I'm Gilda Holman, University of Michigan. And I'm a participant in a study in Seattle organized by the Institute for Systems Biology and now Aravale,
Yep.
which is a scientific wellness company.
Yeah, I
looking
know
at
that.
all kinds of parameters, including microbiome.
Mm-hmm.
So I get data, and it's descriptive, and it's in categories of organisms, but I have no idea what to make of it, really. And they tell me these are high or low, but they're sort of unexplained, high or low for what. So I looked up in your website, and it's a fabulous operation you've built, really wonderful. And there's, as you said, there's some other kinds of citizen science things in other fields that are also amazing.
Yeah.
But there's a clear statement. You say that many have expressed disappointment that there's no actionable finding from the data report. So what is it people are supposed to do, and what are the doctors who, as you just said, order up the tests out of curiosity, just like the patients do? What are they supposed to do with the findings?
It's a great question. So there's a different answer for each of these products. So because, you know, obviously on the wellness side, we can't give actionable information for people that have a diagnosis and suggest they take a specific drug or they stop taking a specific drug. But on the medical side, we can give that guidance to doctors. So I would say on the Explorer side, we make it as actionable as possible in the sense that we tell you what to eat. We tell you, you know, here's what your microbiome is low in, and here are the bacteria that are present in certain foods. So if you eat them, your microbiome, one would hope, take up residence in your microbiome. And if they don't, then, you know, you could try eating different ones or eating more of them, but at least you know, like, if you're eating sauerkraut or if you're eating yogurt for the microbiome purposes, you know, for the purpose of improving your microbiome, you can know, does it in fact do that? So on the Explorer side, it's all about health and wellness and telling you what to eat, essentially, and is your probiotic that you're taking actually taking up residence in your gut? So that's what our current product does on the wellness side. On the SmartGut side, which is kind of the medical doctor-ordered side, what doctors are using it for is to guide treatment. So if you have someone, you know, for your first line, if you are pretty sure it's not IBD, generally what you do is you put people on an elimination diet and you see if that helps, right? So you eliminate foods that commonly cause problems in people with IBS. And you may notice that the patient gets better, but that's kind of, sometimes that's hard to tell, and it's hard to tell what exactly was causing that. So doctors can test initially, recommend a specific diet, test again, and then, for example, if it worked and the patient's fine, but they can't eat any of the foods they want to eat, you can add foods back slowly and say, okay, how is their microbiome changing over time? Or for people that are kind of in that route of, is it Crohn's or is it not Crohn's? You can sort of, if it very clearly points toward Crohn's, you can try some of the treatments for Crohn's and see if they work, see if they actually improve the microbiome of the patient. So that's on the medical side. So I think the answers are very different on each side, but it should be actionable in the sense on one side, very bluntly, we tell you what you should eat. And on the other side, very bluntly, we tell you, is the treatment that you're about to suggest likely to work, basically.
Ask your doctor.
I'm sorry, what?
Ask your doctor.
Well, on the medical side, ask your doctor. On the other side, try the foods that you think may be beneficial and see if they work, basically.
Thank you.
Yeah.
Very interesting talk. Chadri from US FDA. I think what you presented is a very nice example of the data-driven medicine and the challenges we face. One thing I wanted to point out was, like, when you presented the data, you said you don't know what the healthy limits of these things you measure are, so you use that. And then you presented a sensitivity and specificity around 99%. Mm-hmm. So how did you come up with that? Did you decide it, because this is outside the healthy range, it's 99%? Or
that's a very good question. So it's sensitivity and specificity of detecting the specific bacteria. Right? So whether or not, there are two steps to this process. One is, are you detecting what you think you're detecting? Like, do we think it's one bacteria when it's really a different bacteria? And then there is now that we know which bacteria it is, assuming we got the first part right, how much of that should you have, right? And those are two different questions. So we answer both of those questions. So the first question is, how do you know that you're detecting what you're detecting? We wrote, this is in our PLOS paper, we can talk about that in more detail. Essentially, it's, checking to make sure that you have perfect alignment along the sequences that, from that specific bacteria. First, if you verify that the bacteria is what you think it is, then you verify that every, ACT and G that you're reading across the sequence of that DNA actually matches that DNA, and then you can say, that's why we know we have good sensitivity, because we only detect that thing that we say we're detecting. So that's like step one. Did we detect what we say we're detecting? And then step two is, okay, great, but is that useful? How do I know if this is healthy? And for those, we looked at these 897 people and we said, here is how much of this specific bacteria healthy people have in our cohort. This is what is low, this is what is normal, and this is what is high for these specific bacteria. And then we said, okay, you fall here, you're normal, or you have more than the average healthy person, or you have less than the average healthy person. So these two things are calculated separately. It's not sensitivity of detecting whether or not you're healthy. It's sensitivity of detecting whether or not we detected the actual bacteria that we said we detected. And then it's a really trivial matter to say, okay, you had 1,000 of them and someone else had 100,000 of them. Okay, then you're low, basically.
Yeah,
does that answer your question?
Yeah. One quick follow-up. So do you also separately validate that, or is this just one-time verification?
Do we separate what? I'm sorry.
You can do a verification, and you can also secondary validate it for the sensitivity.
So we did. Yeah. So we did. We did our CAP validation. So this is a lab-developed test. So it's the validation is part of our CAP inspection and all that sort of stuff. We did a validation, an analytical validation, which is part of CAP, and then we did a kind of every correlation that we cite on the test is related to specific peer-reviewed literature that we then cite in the footnotes of the test. So anyone can look up for themselves, oh, this is why they say X is correlated with Y, because here are the research papers that prove that. So I hope that answers your question. We can talk more about the details of that if you want.
Okay, thank you for the great presentation. I hear a lot about microbiome. Just a few months ago, I was at the meeting where Larry Smart was a keynote speaker. He had talked about his microbiome that he's sequencing every 2 weeks.
Is this Mike Snyder, maybe?
Yeah.
He's known for that.
So I was wondering, you just talking about the actionable recommendation that you give based on the test. Do you actually follow up to see if anything helps?
I'm sorry, does the follow?
You do the test, and then you mentioned that you give recommendations about food that can increase this or that.
Mm-hmm.
And then do you follow up with participants to see if that helped?
Yeah, that's a very good question. So, yes, we follow. So people do a sample, and then they make some change that they want to make, whether that's changing their diet or that's some other experiment that they're doing, that maybe they're traveling, maybe it's, it could be intentional or unintentional. Maybe they took antibiotics and then they want to see how that changes their gut. We let participants kind of lead that process. So we don't, we send them an email saying, yay, here are your results. Would you like to learn more? But we don't, they're not, one of the interesting things about this is that typically you design a study with a very rigid protocol and everyone gets tested on this, specific schedule. And some of the sub-studies within our data set do that. I think one of the really interesting things that we've been able to do is, because we're kind of the union of all these different studies, one of the cool things that we can do is we don't necessarily have to keep participants to a study they may or may not be compliant with. So, I don't know if this is the short answer, the long answer to your question. Basically, people test when they want to test, unless they're part of a specific sub-study with a research partner, and then we just monitor what happened in between and how that changes their microbiome.
Okay.
Sorry, I hope I answered your question.
Thank you, Jessica. That was
Sure.
that was excellent. And also, I want to thank you personally, because Cindy Duke, the study on fertility
yeah.
in women, is a study that I did with Cindy and submitted.
Oh, that's so great.
We're
She's
very
amazing.
excited about that. Yes.
Yeah,
So
me
one
too.
of the issues I think that has to be very clear, and why I myself and my team is very interested and started doing N of 1 research over 20 years ago, is that when you look at results, they're not necessarily association and cause and effect.
Right.
And that's what I think is troubling about the microbiome. So when you look at an individual and then you look at averages and what's out in the population, you're not going to really be able to say, well, this is what is causing diabetes or obesity or problems with allergies. But by following an individual, and here's where the beauty of precision medicine is, by looking at an N of 1 and drilling down to little data from big data, and following it on and off again and testing as you propose, you might be able to detect changes as a person improves over time or doesn't as you make changes in the clinic. And that's where it really might make a difference. Right now, I think the state of the art, and I think you would agree with Rob Knight, unless you're Larry Smarr and you're collecting freezers and refrigerators of poop and looking at it all the time, you're not really going to be able to detect these subtle differences, because the microbiome changes day to day.
Yeah, I think I would say you kind of need to do both, right? Like, in order to make a clinical test, for regulatory reasons, there's a static clinical test, right? Like, we can't make a different clinical test for each person. That's just not how the system works, right? You have to make one clinical test. And we want to make that test comprehensive enough that it's a useful guide for people to do either what we can call their N of 1 experiments, or we can just call clinical practice, where they work with their doctor to try to improve their condition, right? So I would say that causality is not something we're aiming to establish here. I would leave causality to the basic research scientists like Rob Knight, who are looking to understand underlying mechanisms, and that's not what we're trying to do at all. And I think it's great that people are trying to do that, because we use that in, as supporting data for our research, and it's just because it moves science forward, right? Like, understanding these mechanisms at a really deep level is really valuable and good for science writ large. That's not what we do, though. What we do is we just gather live data. We use that to collect these healthy ranges to then guide treatment. I wouldn't say that, if you look at a healthy range, the idea is that ideally that would apply to you. It's a good starting point, but I agree with you that if your personal experience with your microbiome is totally different than that healthy range, then, as with any test, like, disregard it. There are people who have high cholesterol tests and are, don't have high cholesterol in the typical way that we think about that causing problems with their health. As with any test, like, the actual data about yourself is more valuable than general data about anyone. But I would take issue with the idea that if it's not causative, it's not valuable, because I think that there are a lot of things that, to wait for the perfect causal data to show that you understand every perfect mechanism before you can treat anyone or use it in any way to guide treatment, I think is a mistake, because we're all going to sit around waiting and having, either being sick or dying while we wait for someone to find the perfect mechanism.
No, I think
Yeah.
that's an excellent point. It's all multifactorial, and when
Yeah.
you drill into all the variables and put it together and connect the dots, that's where you can figure out something.
Yeah.
But if you look at everything as averages and regression to the mean, which is most of evidence-based medicine,
I know.
not that you can't use that as a basis, you're going to be missing what's at the tail end. And those
That's right.
tails
And we're
are-
all at the
are
tail
where
end of
we
some
all are,
distribution.
right.
Yeah. No, I agree with you.
Thank
And the more that we can do that, I mean, I'll just add one little point about that. I think that the more that we can do that, the better we're serving patients, right? Like the better the test is. And, you know, over time, we hope that SmartGut, which has only been around for like 7 months at this point, will become much more specific, and we won't just have one SmartGut that has, you know, one set of healthy ranges. We'll have something that's much more guided toward each individual.
Thank you.
Yeah. You want this one?
Oh, Aaron Aben from Autoimmune Registry. So I'm the third person now to bring up Larry Smarr, who gave a great presentation out at Transmart meeting last fall. And what was remarkable, that my takeaway was that his symptoms did not correlate with the bad bacteria in his gut. So comment on that or take some other questions.
So I haven't talked to him in a few years, so I don't know the latest on Larry Smarr's gut. I don't know if anyone knows who this guy is. He's a professor. It's funny that we're all discussing his gut bacteria. He's a professor at UCSD. He was an early pioneer in computer science. He has Crohn's disease, and he's gotten really interested in doing deep sequencing, very frequent deep sequencing of his gut. At one point, he was the person who had the most sequenced gut in the world. He may still be that person. He has a model of his colon up on the wall in his research institute. He's a really interesting guy. You guys should meet him at some point. But basically, I don't know the latest on what he's found. I know that when we were working more closely with him, we found that he was comparing some of his sequencing methods to our sequencing methods and things like that. I do know that I think this picture of like good bacteria and bad bacteria is way too simplistic. These are really, as she said, very complex multifactorial conditions, and I think it's more about what tends to be more associated with this subtype versus that subtype instead of, you know, this is good and this is bad and you should have more good and less bad. So that I know that much, but I don't know all the latest about Larry's gut.
The last question. Thank you so much for your work. My professional background is in pattern recognition in both technological and social systems at MIT. So I was curious, would you care to share any thoughts about what you're doing in the constructed environment, office environment, as it intersects with the physiological? There's so much in the news these days about the biome of the built environment.
Yeah, no, that's really interesting. We decided, so early on we had a lot of questions internally like, should we do the pet biome and should we do the microbiome of buildings and what about soil and what about the ocean and all sorts of things. And we decided just to focus on humans. So we did some very early studies where we sequence people's air filters and things like that, but we don't do that anymore. There's a company called Phylogen, started by Jessica Green. She's a researcher at university, or was a researcher. Another Jessica. There's like a lot of Jessicas. Yeah, her name's Jessica Green. She was at University of Oregon. Now she started a company called Phylogen, which that's what they do. They do microbiome of buildings. Like that's their whole mission. From our perspective, if it affects the human, we will learn about it, but we don't do, environmental sequencing of, chairs and tables and insulation and things like that.
All right. Thank you so much, Jeff.
Yeah, sure. Thank you.
So thanks again to our sponsors, Amazon Web Services. Thanks everybody for coming. Thanks to all our wonderful speakers, and look forward to seeing you in a year from now. Thank you very much.